Hello friends, welcome to Cadence tutorial. I am Madan Kumar Jha and in this video I am going to explain about how to design a 5-stage ring oscillator in Cadence Virtuoso without instantiating the cell view. In this video I will create 5-stage schematic in the one workspace. Okay, so go to new, then in cell view, ring oscillator. In library Cadence tutorial I am going to design a ring oscillator 5 stage. Okay, this is the name. Okay, then in this workspace I will design 5 stage. So press I, go to GPDK 180, then here press PMOS. So after typing PMOS you will get the symbol of a PMOS. So use this symbol here. Since I have to make a schematic of a 5 inverter for this, so I'm going to use 5 PMOS and 5 NMOS. Then again press I, then GPDK 180, type NMOS. So this is the symbol of NMOS. Now I'm going to use 5 NMOS here else again. So this grid lines help you to align it. The PMOS should be aligned with NMOS for a good schematic. Okay, now 1 2 3 4 5. Okay, then using wire you will connect the drain of PMOS to the drain of NMOS for each stage, and the gate of PMOS with gate of NMOS to each stage. So you will see the difficulties what I am facing. I have to create the inverter each time, and I have to use this wire for connecting this all each time. But if I will generate the symbol, then I can instance that without any difficulties, and I will use that every time when I required that. Okay, so that is the benefit of generating a symbol and instantiating them for any circuit designs like a ring oscillator or any other. Then again press W, then connect the output of this inverter to the input of this inverter. So use this. Okay, this to this, similarly this to this, and vice versa, this to this. Okay, and the output of the last stage should be fed input with the first stage. Okay, so this is the schematic. Again press I. In analog library you will find ground and VDC. So BDC, oh sorry, in analog library, so I have to type library name. So analog lib, then here you will find VDC, BDC. So set the DC voltage to 1.8 volt. Okay, then use it here. Escape, press I. Then in analog library you will find ground. So type ground. This is the schematic of a ground. Then press I. You will find here VDD, VDD. Use that VDD here, 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 and everywhere where PMOS source is. Okay, then again press I. In analog library you will get ground. So this is a symbol of ground. I am going to use it here. Okay, the body of the bulk or body of the PMOS should be connected with VDD, so I'm going to connect this. And the bulk of NMOS should be connected to ground, so click on main bulk, then connect with ground or source. Okay, escape. Then create a pin which is output in nature and give this name to out. Okay, then flip horizontal and use here. Okay, then using wire connect this output pin with this. Okay, so this is the schematic. Since it is a ring oscillator, so no need to provide any input voltage. Then after check and save, go to ADEL in launch section, then right click here, edit, give a stop time to 100 micro, sorry, 1 micro. Okay, then moderate. Okay, uh, if you want to change the, okay, so here first I have to see the output. Okay, now go to edit, in output section from design, select that output. Okay, then press OK, then go to tools, in calculator click on BT, then go to design and select the output node, so it will select that output node. Okay, in calculator, then in function panel you have to type for frequency, so you will get frequency here. After clicking this frequency, it will automatically come here, so this is the frequency. Then send buffer expression to AD output, so when you click it, it will go to output section. Then close this. You can see in ADAL the frequency expression of output have also come. Then one more step is required. Go to simulation, then in convergence set initial condition. So since it is a ring oscillator, so how it will decide that which node is 1 initially, or this node is 1 initially, or this is 0. Okay, so I have to give or assign any initial condition to that node. So go to initial condition, then here node voltage is 0. You can also choose 1.8. Okay, so I am choosing it 0. Then go to the node, so you can select any node or any net, this or this. So I'm selecting the input node first, so you can see here it is 0 have come. Okay, so the initial condition of this net is 0. Here also it have come, out voltage is 0. Then press OK. Then in ADEL go to setup, check model libraries, so here only GPTK 180 have checked, so no need to worry. Then run the simulation. Here the so this is the output section. You can change it width, or you can see this is the output of a ring oscillator. This is oscillating in nature. Okay, so I'm going to change its color no, type to solid, sorry, style to solid. So you can see this is our ring oscillator output, and its frequency is 3.21 gigahertz. I think it will be in gigahertz. Yeah, so it is 3.21 gigahertz. So since I haven't used any capacitance here, if I will use the capacitance here, then its frequency will be decreased. Okay, but I haven't used any capacitance here. So actually there is a parasitic capacitance of this PMOS and NMOS, and that parasitic capacitance uh, no, lead to uh, yes, this parasitic capacitance will lead to change its or set this output frequency to 3.21 gigahertz. Okay, now if you want, then I will change how this how this output frequency will reduce by using a parasitic capacitance. So for that, press I, then in analog library type P capacitor. Okay, so this is the parasitic capacitance symbol, then use it here, 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 here. uh, Whenever you will change the parasitic capacitance, or whenever you will use a parasitic capacitance to any stage, you have to use same parasitic capacitance to each stage, because it's the ring oscillator. So if you will use it only in one stage, then uh, it will change the output frequency for each stage, which will be not good, and it will not uniform. Okay, so now I have to use the ground also for the one terminal of this parasitic capacitance. So I'm selecting ground, then use this ground here, 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 then escape, press W, then check and save. After checking and save, close this, go to ADL, and then run this. Now you can see this is the output of this ring oscillator when I have used a parasitic capacitance of 1 picofarad in each stage. Okay, and the output frequency this time is 47.358 megahertz. Okay, so it have reduced from 3 gigahertz to 47 megahertz. Okay, now if you increase this capacitance, okay, then the frequency will reduce. If we reduce this capacitance, then frequency will increase. So you can adjust the frequency accordingly by changing this capacitance value. Okay, you can make this capacitance variable here by press on Q and go to properties. Then if you want to change, make it variable, you should give any variable name here, so it will change to C picofarad. Then you have to make the same variable to each stage. Okay, and then in ADEL you should copy this from cell view. Then you have to give a fixed value like 10 picofarad, 1 picofarad, and what you want to, so at what particular value you want to see the output frequency, you can assign that value to here. Okay, and then you should run these simulations. After that, after running the simulation, you will get the output waveform and output frequency. Okay, so you can do this. I have explained it in my earlier videos of ring oscillator using instantiating symbol. Okay, so you can also watch that video for this. Okay, thank you.